Hi, so today we're going to solve question 4.55, which is in the chapter of the forces. So the question says, an athlete whose mass is 90 kilograms is performing weightlifting exercises. Starting from from rest position, he lifts with a constant acceleration, a barbell with a weight of 490 newtons. He lifts the barbell a distance of 0.6 meters in 1.6 seconds. So the first part of this question asks us to do a free body diagram. So for this question, there's supposed to be two free body diagrams because one for the barbell, the other one for the athlete. So the first one is for the barbell. It's going to look like this. So this is the barbell. It's going to have the weight, which we're going to say WB equals mg. And there is the force applied by the athlete. Okay, so that's for the barbell. For the athlete, this guy right here, he's going to have three forces. So it's going to look like this. The normal force and the weight, which equals WA, equals MAG. This is MBG. And there's the force applied in the other direction. Okay, so now these are the free body diagrams. We have the force applied to the other side because, as Newton's law says, for every action there's a reaction. So there's a force applied going up, so it's supposed to be going down to the other side. So going to part B, which says find the total force as he exerts on the ground as he lifts. So before doing that, we need to go back to the question and get the key components for us to solve this problem. So an athlete whose mass is 90 kilograms. So we got MA equals 90 kilograms. Is performing weightlifting starting from the rest position. Rest position means V initial equals 0. He lifts with a constant acceleration. So by saying this sentence, we can go back to chapter 2 and use the position formula that we used to have, so we can solve for the acceleration. So the barbell's weight, so WB equals 490 newtons. So he lifts the barbell a distance of, so the distance D equals 0.6 meters in time, which is 1.6 seconds. Okay, so let's try to get the other components out of the free body diagram. So we have for the barbell, we have the weight for it. So barbell equals 490. So to get the mass of the barbell, it's going to be, so WB equals MBG. So to get the mass, we need to solve for MB. So divide this by both sides. So it's going to be 490 divided by 9.8 equals 490 divided by 9.8, which is going to give us 50 kilograms. Okay, so now we found the mass for the barbell. So going to the athlete, we have his mass, but we don't have the weight. So going here, WA equals MA times not G but times A, which is the acceleration. No, my bad, mg, which is the gravity. So we have the mass, which is 90, times the gravity, 9.8. That's going to give us 882 newtons. Okay, so here, MA equals 882 newtons. Okay, now as we said, starting from rest and constant acceleration, we can use not Newton's law, the position formula, which equals to y minus y initial equals v initial times t plus 1 over 2 a t squared. So as we said, we have the starting from rest, so v initial equals to 0, so this part equals to 0, and we're trying to solve for a. So a equals, we're going to multiply both sides, so it's going to be 2 times y minus y initial, and we're going to divide it by t squared. So plugging in the numbers we have, it's going to be 2 times the distance we have is 0.6 minus 0, which is 0.6, divided by the time we have 1.6 squared. So by that we get the acceleration. 2 times 0.6 divided by 1.6 squared, we get 0.469 meters per second squared. So now we have the acceleration and we have the weight. Now we can use the formula of the sum of the forces equals ma. So plugging in the numbers, we have the 490 plus, we're going to have the weight times the acceleration, which we have here, and times a. The weight is 50. Multiply that by 0.469, and we get 490 plus 50 times 0.469. It's going to be equal to 513 newtons. Okay, so to get the total force that his feet exerts on the ground as he lifts, we have this for the barbell, the weight of the barbell, and the force applied. And we need to add what we got right here, which is the weight of the athlete. So the final answer is going to be what we got here, which is 513 newtons plus 882 newtons. That's going to equal to, it's going to equal to 1395 newtons. And this equals